this is, I should say before we get started as well, this is very much a beginner-friendly talk, so I don't assume you have any prior knowledge of Elm. It's fine if you've never even heard of it. I also don't assume you have any knowledge of front-end development. So there's lots of really excellent Elm talks out there, but most of them have the same kind of public in mind. So most of them are directed at JavaScript developers and trying to convince JavaScript developers that, okay, we've had enough of undefined is not a function, and it's about time we introduce things like function purity and types, and basically things that will give you compile time errors instead of runtime errors. Now, this being a functional programming conference, I assume that I'm preaching to the converted here. So hopefully you already are all convinced of that you know, functional purity and whatnot is good, and ideally types as well. And so I won't dwell on that too much. So instead I'll just focus on what's been my experience as a backend developer. So that's kind of the audience that I have in mind, people that maybe have more experience with backend development. And ideally already have experience, prior experience with an FP language. In my case, this was Scala, but I'm sure it works just as fine if it's Haskell or Camel, whatever. And yeah, like I said, I don't assume you have any prior UI development experience, although if you're attending this talk, hopefully you have an interest at least in building UIs at some point. And then the last thing that I assumed is, well, someone who finds himself in the same situation that I was in when I started learning Elm, which is that, okay, I need to build UIs, but I want to be productive quickly. I don't really want to spend 6 months learning the whole JavaScript ecosystem, assuming you can ever learn the JavaScript ecosystem, because apparently every 6 weeks or so a new framework comes out, and whatever you knew before is already out of date. And also someone who doesn't want to compromise their project's future scalability. So whatever language, whatever technology you pick, hopefully is not something that eventually you will outgrow and you'll have to rewrite everything in a different language. This is a situation I found myself in back in the days when I worked in Python. Python is amazing to build a very simple, small application, but then I found that as I grew the application, I actually wanted to move to something like Scala. So I often found myself in a situation where I had to rewrite things. And the other thing that I mean by project scalability is ideally you can bring people in at some point to work on your project together. So something with not too steep a learning curve, ideally. So what is Elm? I would define it as follows. I would define it as a strongly typed, purely functional DSL for building browser-based applications. So if we start to unpack that, Elm syntax looks something like this. If you write Haskell, that probably looks very familiar already. Oh, okay. Yeah, so you probably recognize a bunch of things here that you may be used to already. We have ADTs. So you have an example of a sum type up there. We have things like pattern matching, and the compiler will do exhaustive checks when you use pattern match. We have function currying. So this update method here, if you look at the signature, all the types in the signature, except for the last one. These are the types of input arguments, and then the last one is the return type, right? So all the kind of stuff that you may have gotten used if you've used FP before, and that you may have come to like. I come from the Scala world, and in the Scala world, we like to think that we have a very concise and very nice language, because most of us have used Java before. And compared to Java, anything will look concise, but as a quick comparison, this is how you do the exact same thing in Scala versus Elm. So yeah, you can do even better than Scala. And personally, I always enjoy, as compact a syntax as possible. Okay, and then the second part of this definition was that Elm is a DSL for building browser-based applications. So it's not a general-purpose programming language. You will find, if you look online, you'll find people that have tried to go a little bit against the grain. So I think there's a library for running Elm inside of AWS Lambda functions. There's also a talk on YouTube of someone who runs Elm on a robot. But if you try and do that, yeah, you'll find yourself, going against the language and probably having to write quite a bit of boilerplate. Really, it's a language that was designed to build single-page applications that run in the browser. It's been designed to do one thing and do it really, really well, rather than be a general-purpose language. So as anything that runs in a browser, at some point, you need to output JavaScript, right? It's the universal language. So this is how you would package an Elm project, effectively. So you have a bunch of Elm files containing your code. You run that through the Elm compiler, and out come a JavaScript file, which you then need to import into a small HTML file. So the HTML file, you need to provide is something like this. If you've used applications like, if you use frameworks like React or Vue, it will be very similar. So effectively, you need to import what came out of the Elm compiler. You need to define a div inside your application body onto which you're going to mount your application. Right. So this is the element in your application which everything that happens inside your Elm application will be displayed. And that's it. That's all that's required. Another thing you might want to consider as well before you pick a particular front-end framework is like how performant it's going to be. So in the past, maybe 10, 15 years or so, we've switched from having HTML being rendered on the browser side, and every time the user interacts with the page, you know, you send a request to the server, and the server will send you an entire re-rendered HTML page with all the updates necessary. We've switched from that model to something that is referred to as single-page applications, where you download a big JavaScript bundle when you first access the web page, and then as you interact with that page, the only thing that gets re-rendered are the particular elements in your page that are supposed to have changed. So that makes for a much more fluid user experience. You don't have, you know, like a blank, like small blanks between pages reloads. And things that matter when you build this type of application are, number one, how big is that initial JavaScript bundle that you're going to have to download? Because the bigger it is, the more the user is going to have to wait. And Elm does pretty well on that. So obviously the size of that bundle depends not just on the complexity of your application, but on all the dependencies that you need to package with it. And Elm is pretty small as a framework. Like you can see, it's a little bit bigger than Vue. Certainly looks better than combinations of React and Angular. So yeah, not something to worry about here. I wouldn't always try to aim to pick the smallest one, but you just, you know, when you pick a framework, you want to make sure you don't pick something at a tail end down there that might hold you back later on. And then the second thing that matters is, okay, when the user interacts with your page is how fast can you update the DOM, right, in response to those interactions. So that's the other metric you'd want to look at. And again, Elm is performing pretty well compared to mainstream frameworks. So yeah, nothing to worry about there. These benchmarks are a few years old now. I think they're about 5 years old because they're, you know, not. It takes quite a bit of work for someone to run them, but as far as I'm aware, there hasn't been any drastic changes in the ranking there. Okay, one question you might be asking is Elm still relevant in 2024? And I think the main reason people ask this question is if you look at the Elm compiler, the last release is nearly 5 years old. If you look at the history of Elm releases, obviously, you know, as in most languages, you'll have lots of releases. The language is fairly young, and as it matures at some point, they kind of start tailing off. In the case of Elm, I guess we have reached a point where, you know, the compiler is mature enough that you can do most of what you would want to do in a traditional single-page application, and there hasn't really been any need recently to add anything else to it. Someone even went through the trouble of actually making a web page to explain whether Elm is dead or not, and the answer is, well, no. They'll explain it far better than I can. But there's a bunch of arguments for that, which basically boil down to A, the Elm community is very active. There are new packages being released every week. So just because the core of the language itself is not moving anymore doesn't mean the language has become stagnant. The second thing is it's also, you know, the Elm language itself moving slowly is a factor of both how it's being developed. So it's a language that doesn't have a big corporate backing it up. It's basically one guy working on it. So there's no big corporate backing, no academic backing. So if you compare it to other languages that have maybe half a dozen people working on them, you cannot quite expect things to move at the same pace. And then the other thing is also the way Elm's creator likes to work. So he explains, for example, how when you look at other languages, you'll kind of see, so you'll see someone, a user raise an issue on the GitHub repo for that language, and then the language maintainers will try and fix that issue. And then someone else, a few weeks later, will raise another issue that's not quite the same, but it's kind of related. And again, the maintainer will try and add a patch that maybe fix that other issue. And so you can imagine that the language evolves in a way that you have that kind of very noisy convergence towards solutions to particular issues. Whereas the creator of Elm said that he actually much prefer to work in such a way that he'll wait for users, you know, to raise a bunch of issues. He won't try and address them right away. And then he'll kind of look at all the issues that have been raised and he'll try and cluster them. So try and find the ones that are related to really get to the core of the problem. And once he's done that, he likes to list the possible solution and again take his time to try and come up with the ideal solution. So the idea is, let's not just try and release the first thing we can think of, but let's make sure we really understand the problems that are being raised here and that we come up with the best possible solution to those problems. So it's also a choice to have that kind of slow, I guess, yeah, that slow pace of development. And then the last thing is, yeah, I mean, if you're talking about front-end anyway, anything other than React is probably always ever going to be like as in a minority, and it's, yeah, anything compared to React kind of looks dead. You can't expect the same pace of release of any other language. All right, so what makes Elm as a language so special? I think the main thing is that it really was designed with developer happiness in mind. If some of you remember Ruby on Rails, that's probably the other big framework that was designed with that in mind. And that means a bunch of things. That means, one, that it's super easy to learn. So the language is extremely, you can learn it in literally a few hours. There's a great guide online on the official Elm website. And at a very leisurely pace, in one day, maybe 1 day and a half, you are done learning the language. And then maybe if you spend another day trying to build an application to really get a feel for it, by this point you are proficient in Elm. There are no things such as, so there's no inheritance, there's no class per se. You have ADTs, so you have some types, product types, that's about it. There's no higher kinded types. So all those monads, functors, whatnot, you can all ignore it. It's not there in Elm. And that's by choice. Yeah, again, the creator of Elm says, until we have a good use case for it, we don't think the trade-off between language complexity and the features it would bring in is worthwhile. And then the other thing is the language comes with battery included. So it is one of the first things that might be confusing about Elm is it's both a language and a framework. Right? It's not like with JavaScript where you have JavaScript itself and then you need to bring in React and a bunch of other things to actually build a project. With Elm, everything comes with batteries included. So this is a history of the things that I had tried before encountering Elm. I got started with Vue.js way back in the day, and it wasn't too bad, except I had to use JavaScript, of course. And yeah, I wasn't too fan of the language at the time. I didn't try TypeScript yet. And then a little bit later, I had tried Scala.js when, at the time, Scala.js was really, it was in the Stone Ages. We didn't have the really good framework that I think we have nowadays. You had to use Scala.js, and then on top of that, you had to bring React. So this was difficult. Like, it wasn't possibly the best choice because already you have a steep learning curve to Scala. So if at any point I needed to bring in someone else into the project, not only do they need to know Scala, they also need to know React. And it was kind of a non-starter for me at this point. I think the situation has improved a lot recently. I just haven't given it another try. And then the last thing I tried before Elm was Next.js, which is React with a bunch of bells and whistles added. So there's server-side rendering, there's a custom router and whatnot. But again, having to work with the whole JavaScript ecosystem was painful enough that yeah, I wasn't entirely convinced by that. If you haven't tried setting up a JavaScript project before, it looks something like that. So first you need to pick your package management tool. Might be something like NPM, Yarn. Then you need a framework, so the thing that's going to update the virtual DOM. Typically React, Vue is pretty similar as well. And then because it's JavaScript that you're working with, what you'll see a lot of UI developers do is they have on one screen, they have the application being rendered, and on the other, they're making changes to it. And you want to have the application all the time running, because as with JavaScript, you forget one semicolon somewhere, and suddenly you're faced with what I call the white screen of death. The whole thing breaks down. And so you kind of need that hot reload functionality to even be able to make any changes to your app. Then you need to do state management. So the way React and Vue started, you have components that are kind of akin to object in object-oriented programming. So components are different elements in your UI, and they can encapsulate a state. And as you can imagine, as the number of components in your application grows, the number of possible routes that these components can take to communicate with one another, well, it grows with the square of the number of components, so it pretty quickly becomes unmanageable. So you need, again, a specific library to do state management. You might want to add strong typing, and I think by this point you can see where this is going. Before you've even written a Hello World application, you have to bundle all these things together, you have to research these different libraries. One solution that the JavaScript ecosystem has come up with to that problem is to build command line applications. So you have like a create React app command line, for example, that will actually build the entire project for you. The thing that I'm not too fond of with these is they feel a little bit magical, right? So outcome a fully built project, but if at some point you want to make any change to it, to any of the libraries, well, if you don't even know how the project was assembled in the first place, it's pretty tricky to make any changes without breaking it. So I've never been very keen on that solution. Yeah, and I think that's one of the reasons Elms shine is, well, you don't need any of that, right? As soon as you install the Elm CLI, you have package management, like you can install dependencies with that. The framework, the virtual DOM updates, this is baked into the language as well. You have a compiler that you can actually trust. So even though they are hot reload tools, you don't necessarily need them. Once your application compiles, you're pretty sure it's not going to explode at runtime. It might not do the right thing, so obviously you'll want to write tests to check your business logic, but at least you know it's not going to blow up. And then again, state management, yeah, you don't need to worry about that. That is baked into the language, strong typing, and so on and so forth, right? So you have everything with just one tool. Okay, so before we go any further, I want to give a quick demo of what a super simple Elm application might look like, just to give you a feel of what it's like to work with Elm. Okay, so this is the application. It's the simplest thing you could think of, right? It's a little counter, and you have buttons to increment and decrement it. This is an example from the official Elm documentation, and the code for it looks something like that. So you need an entry point to your application. Always has to be call main, and it has to be of a type program with a few type parameters. There's a few constructors for it. This is the simplest one. So sandbox is if you're going to build an application that, yes, is interactive, but doesn't need to talk to the outside world, which is our example here, right? We're not making HTTP call. We don't need to talk to the outside world. So that's perfectly fine. And this constructor needs three things. It needs an initial state for the model. So we'll need to define what the model of application is. In this case, since it's just a counter, we can just use a type alias for integer with an initial value of 0. Then we need to tell Elm how you're actually going to render this information. So we need a view method, which is basically a function that will take the model, the state of your application, and will give you back some HTML. And that HTML is capable of issuing messages, which are commands that are issued as the user interacts with the application. So if the user clicks a button, you may issue a particular message as a result. The way you construct the HTML is pretty straightforward. I mean, you can look at the constructors here. It's named the same way as the HTML element you'd want to use. So pretty straightforward to figure out how that bit works. And then the last bit you need to provide is this update function, which tells you the Elm runtime as the user interacts with the application, how does the state need to be updated. So the signature of this method is it takes a message and it takes a model that represents the current state of the application and outcome the updated state. So in this case, depending on whether we get an increment or decrement message, we change the model accordingly. So if I were to attempt to make a tiny change to this application, for example, we want to add an extra button to reset our counter. So I would add this as a message. It's a new type of action that a user can take. And right away you can see the Elm compiler has actually realized that, okay, I'm not checking for all the possible cases in my update function. So it's warned me that I need to fix something here. So what we're going to do is, of course, when the user presses reset, we just want to reset the model back to 0. And our compiler is happy again. But then just to complete our application, we probably want to add a way for the user to actually exercise that reset option. So we'll add a button here. When the user clicks on it, we're going to issue that reset message. And we're just going to put something sensible as the content of that button. Right. And then if we try and compile the application again. So yeah, you compile it with the Elm CLI. It's a command that looks like this. And the output is obviously a little JS file, as we said, which is then loaded inside your HTML page here. So that's all my application is right there. There was the core Elm code here. This is what comes out the compiler. It's not meant to be readable, so don't worry about that bit. And then it's just loaded into an HTML page here, which I point my browser to. And it will refresh this. There you go. We should have our little button. So that's how simple it is to set up small Elm application. And hopefully you can see as well that's how helpful the compiler is. As soon as you break something, the compiler will tell you right away what is wrong with it. Cool. Right. Elm is known to have been a big influence to other languages and framework. I think most famously React. That update function that we saw, where you give a message that represents an action taken by the user in the current state, and you get a new state, well, that's Redux's reducer for you. So they basically took that idea and implemented it in JavaScript. The other thing that Elm is super known for is the compiler, which gives, it was possibly the first language that had a compiler that's actually helpful. And instead of just dumping a stack trace on you and letting you figure out what might be wrong, the compiler not only tries to explain in a human understandable way what is wrong, but it also gives you hints as to how you might fix your problem. So we have a couple examples here, one of which is maybe fairly trivial, the second one is less trivial. I don't know how well we can see the tweets here, but somebody basically tried to define a type alias which is infinitely recursive. And that's not, if you've run into that issue before, it's not necessarily super easy to spot at first. And here the compiler very, very kindly points out what the problem is and suggests how to fix that. Other things that Elm compiler can do is enforce, for example, semantic versioning. Again, because you have a language that is typed, the compiler can tell whether from one release to another of a particular library you have actually broken the signature of any of the functions that your package exposes publicly. And so it can force you to do a major upgrade when it's appropriate. It's influenced languages like Rust, so there's a link to an article here from the Rust team where they explain how they got inspired by Elm and that they're going to try and use it in the future to have more understandable errors in Rust. I believe it's also influenced the team that's worked on Scala-free. I didn't manage to find a reference to an article explaining that, but I believe they've also looked at Elm to try and produce more understandable errors. Okay, so what is it like to actually build and maintain a medium-sized Elm application? So the development environment is pretty simple, right? So you have your Elm CLI, and then there's an extension for Visual Studio Code, which has everything you could possibly need. So there's go-to definition, syntax highlighting, the usual good stuff. I will show you as well the compiler errors, as you've seen there. The only issue that I've had with it in the time that I've used it is sometimes the extension will kind of freeze. So as you make more and more changes to your code, at some point you notice that the go-to definition stops working or something like that. The way to fix it is close the editor, reopen it, and that's it. Like turn it off and on again, and it works. I never got stuck beyond that, so it's pretty decent. So we briefly, so the Elm architecture is kind of like one of the core ideas in Elm. So when we looked at our program, we saw there's an entry point that has to respect a certain signature. So that signature is you have to return a program, and then it takes a few type parameters here. Flags is just something you can use to pass configuration values to your application. So for example, the URL of your server or something like that. And then you need to define your own type for the model, the state of your application, as well as messages, so possible user interactions. And there's a few possible constructors for such a program. They're part of a package called the browser package. And the full constructor looks something like that. So we have Sandbox that we've already looked at, which is, as the name suggests, for applications that do not interact with the outside world. So for a simple counter application like what we just looked at, that's perfect. Then the next level up would be Element. So this one actually allows you to talk to the outside world, and it allows you to do things like send HTTP requests or interrupt, have JavaScript interrupt, and so on and so forth. So talk to things outside of Elm. Document is the same thing as Element, just allows you to control the title of your web page. And an application is if you want to use dynamic routing. So quite often you'll see single page applications where the URL has something like /users, /an ID, and then if you change that ID, the content of the application will change as well. If you want to do that, you can use the application constructor. It's quite a bit more involved. So personally, and the other thing is, once you deploy the application, you need to deploy it with an HTTP server so that you can actually parse that URL. Whereas if you simply use browser element or document, what comes out is that little JavaScript file. You drop that in an S3 bucket. You drop your HTML file as well in S3 bucket, and your application is deployed to production. There's nothing else to do. So it's a whole lot simpler unless you really need dynamic routing, I would always recommend going with Elementor documents. That's perfectly good enough. Yeah, so these are the signatures of the functions you need to provide to the constructor that we just looked at in the case of Sandbox. In the case of Element, so that's the case where you need to talk to the outside world. They're a tiny little bit more complicated. There's really two extra things added here, which are comments and subscriptions, which let you talk to the outside world. So comments denotes the Elm environment, talking to the outside world, so for example, talking to JavaScript, and subscription is the other way around, so information from the outside world coming into the Elm runtime. So the changes you may notice here, when you initialize the state, you not only need to return a model, you could, if you chose to, you could take an action. So for example, if you're building a web page to display some news, the first thing, as someone accesses the application, the first thing you might want to do is make an HTTP request to fetch the latest news. So you can do that there. And then the same thing when a user interacts with the application and you update the state, you can choose to issue a command. So when a user clicks a button, you can choose to make an HTTP request. Right? And subscription, well, again, you use to get information from the outside world. So you may, for example, wish to get the language that the browser is using so that you can translate your website if needed. And this command and subscribe type denotes an asynchronous exchange of messages between the Elm runtime and the outside world. And one thing that's important to understand is, this is purely asynchronous exchange of messages. So one issuing a command does not mean you will get a subscription back. And similarly, subscription may come in without you having issued a command. They're kind of entirely decoupled. There's one situation, I guess, in which you want them to be coupled, which is if you're making HTTP requests, right? You would expect for every request that comes out to eventually get a response. Elm has, there's a library that's been built on top of Elm in the standard library. So you don't need to worry about that yourself, because obviously there's quite a bit of boilerplate to make sure that as you issue the command, you'll get a subscription back, and you map it exactly to the correct request that you sent out. So when you want to make things like HTTP requests in Elm, you always have to define two types of messages, two types of events that can happen of your application. One is take the actual request, make the actual request, and the other one is how do you handle the response when it eventually comes in. And every sort of interaction with the outside world looks something like that in Elm. It's the same if you do JavaScript interrupt this, it's always in two steps. This way is one, take the action, and B, actually handle the consequences of that action. Okay, I think we only have a few minutes, so I'll try and skip through that bit pretty quickly. JavaScript interrupt is done via something called ports. So you can define your own port modules. Again, whenever you need to talk to the outside world, you'll have a port with a return type of command. Whenever you need to get information from the outside world, you will have a return type of subscription. So in this case, this is a WebSocket module example where I can connect to an external WebSocket, and then I can receive messages from this WebSocket and do something with them. And you need to not only define what this looks like in Elm, you also need to do the same thing on JavaScript side. Right? So this would look something like that. If you're interested in more detail, I have a full-fledged application with this that you can use as an example. But the whole point of it is interaction with JavaScript is possible, and it's fairly straightforward to do. The last bit, I think the dreaded thing for every backend developer going to the front end is CSS. There is an Elm package to do it, to do type CSS if you want it. My recommendation, frankly, here would be just don't do it. Don't bother. Bring in a framework. So you certainly will have heard of things like Bootstrap, probably Bulma as well. All you need to do is you need to import that framework into the HTML file that we referred to in your project. And then you can style elements as follows. You just give the class that have been predefined in the framework to different HTML elements that you have in your application, and you are done with it. So I would not bother. I wouldn't bother with CSS. So, in conclusion, why should you use Elm? First thing is it's a very low investment. Right? You can learn the language in literally a few hours. So, worst case scenario, you come out of that experiment and you're like, I don't like the language, I never want to use it again. Well, you haven't lost 6 months learning a language before realizing that. It's a great entry point into UI development. For me as a backend developer, it's the lowest effort entry point in backend development. Like, it's so much simpler to get started with than JavaScript. And the last thing is it will make you a better developer because it is a purely functional language. So I come from the Scala world, and a lot of people that arrive to Scala don't necessarily have prior FP experience. And Scala gives you a few escape hatches. Right? You can, there's a few methods you can call head on the list, for example, and that will throw an exception if you have an empty list. Scala allows you to do things like this. And sometimes it takes beginners a bit of time to get used to this. With Elm, you'll be forced to do things the right way. Right? There's no escape hatch possible. So even if you never choose to use Elm in the future, just the experience of being forced to do things properly will make you a better developer in Scala or whatever else you choose to use in the future. So for that alone, it's worthwhile as well. Why should you not bother learning Elm? I was going to say that to find a job. I met a few people at the speakers' dinner yesterday who apparently have, work with Elm and get paid for it. So that might not be entirely accurate. But yeah, if you want to get a job as a UI developer, I guess React and TypeScript are still the way to go. Cool, I think we'll end there. Thank you.
Thank you. We have time for one question.
Very quick one. Just a very quick one. Thank you for the presentation. It was great. You were using an extension in VS Code that was not the default one, like the most popular one. Mm-hmm. Is that something new, or is there a different reason to use it?
So I think the default one is actually, let me see if I can show you in VS Code. I think the default one is out of date now. Like they haven't removed it. But if I search for it, so that would have been the default one, and I think it's been deprecated now. Okay. And somehow it's still, showing up in there.
Okay, thank you.
All right, let's thank our speaker again.